Okay, this video is here to help you out with L'Hopital's rule. And L'Hopital's rule is something we use when we're trying to find limits. It allows us to find limits of fractions that are indeterminate. Ooh. It's a terrible N. We'll live with it though. That are indeterminate. One where they take the form where two things combined don't necessarily have an answer. This, that, this. Anywhere where those things come into play. L'Hopital's problems usually fall into one of four categories. They fall into polynomials, where you'll have exponents and degrees over others. That'd be the limit as x approaches 0. On those, you just keep going. You work them until the problems are gone. The second type is when they are sinusoids. And you'll see those in the problems we're going to work on now. What you usually do with sinusoids is you L'Hopital, and then you're going to try to cancel things. And then the next types are LNs. And LNs look like the scariest, but they end up being some of the easier ones, because you're basically going to L'Hopital them once. And what will happen is you'll get 1 over something times something, and things will usually cancel. And the last type for today will be things with e to the x in it. Things with e to the x will usually simplify, or you always got to remember that e to the 0 is 1. A couple key points before we begin when we're dealing with LNs. The argument of LN has to be greater than 0. As a matter of fact, ln of a negative number will be undefined. And just so you know, the ln of ln of 0 will also be undefined. But the question that comes up as often is, what is the ln of 1 equal to? Well, I'll write it like this. I'll change it to the base e. To what power equals 1? Well, any base to the 0th power equals 1. So with any logs or any ln's, whenever we have a 1 inside the argument, the answer is going to be 0. Okay, let's take a look at our problems for tonight. Okay, here we go. Actually, I think the first problem ends up being the hardest problem. Remember when we're working with sines and cosines and tangents, so cool, 2. Okay, so if I put in 0 over 0, I will get back 0 over undefined. The tangent of 0 is 0. ln of 0 is undefined, so this is indeterminate. It combines two of those. So I'm going to L'Hopital this one, always bringing the limit with me. So the reason for the 0 from the plus side is because we can't have negative numbers in the ln. So it's going to be 5 times the derivative of ln of something is 1 over that something, times the derivative of sine, which is cosine of x, over the derivative of the ln of the tangent of something is 1 over tangent something times secant squared x. Now at this point, if I try stuffing things in, you can see how the problem looks like it got more complicated. Whenever you're dealing with trig, you're always going to try to simplify and bring everything to the top if possible. So what I'm going to do is I'm going to turn everything into sine or cosine. 0. Like I said, no, this is the hardest problem here, I believe. I left out the x's just temporarily. You can see I converted everything to sines or cosines. And now I'm going to bring this up to the top. So it's going to be the limit as x approaches 0 of 5 times cosine x over sine of x. Remember, when it comes to the top, it just flips. So I'm going to bring this up now. Times sine of x over cosine of x times cosine squared x. And now if you look, cancel. The cosine of 0 is 1. 1 squared is 1. 1 times 5 is 5. This is the common way to approach these trig functions. The next one, number 2, has an ln in it. I kind of know which way this is going to go. Let's take a look at it. I fill in 0. I have 0 over undefined. So this is a L'Hopitalable problem. So I'll fill it in, the limit. As x approaches 0. Derivative of 5x is 5. Derivative of ln of x plus 1 is 1 over x plus 1 times the derivative of the inside of this, which is 1. Now, I can try to simplify and maneuver things around, but I already know because I just have a constant on the top, I'm probably going to have an answer. So this is 5 over, I fill in my 0, I get 5 over 1 over 1 times 1, which is 5 over 1, which once again equals 5. Number 3, a much shorter one. I'm going to put in infinity, and I'll get infinity over infinity. Once again, two forms that make this indeterminate. So I'm going to do my L'Hopital. Derivative of x is 1. Derivative of ln of x is 1 over x. And a bunch of ways I can think about this. If I have a fraction like this, I'll often try to bring this up to the top. I'll take it and flip it. As the limit as x approaches infinity of 1 times x over 1. If I fill in infinity into x, I get infinity. Another way to think about it is I can come back to here. If I fill it in, it's 1 over infinity. 1 over infinity with limits is the same as 0, and 1 over 0 in limits is the same as infinity. When you put it on the bottom, it just becomes the opposite of what it was. Let's take a look at number 4. Oh, I like this one. This one looks like it's going to be easy. I'm going to fill in the negative 3 to start. 9 minus 9 over 3, negative 3 plus 3. I've got 0 over 0. Indeterminate, so I'm going to fill it in. Okay, so it's 2x plus 3 over 1. So at this point, I'm going to be done on this step. I'm going to fill in my negative 3. I get negative 6 plus 3, which is negative 3 over 1, which equals negative 3. And now I must have done something wrong. Oh, yeah, look at that. It's Lindsay's fault. There was a negative sign to begin with on the problem out there. Doesn't change the original answer, but it does change the final answer to be positive 3. Okay, so on number 5, I'm heading to negative 1. I'm going to fill in my negative 1, and I'm going to get 0 over undefined. Now, I don't like these parentheses, so I'm going to eliminate parentheses before I begin working. I'll get 3x squared minus 3 over ln of x squared. I did not take the derivative yet. I just got rid of that extra set of parentheses. Now I'll L'Hopital it. So it becomes 6x over 1 over x squared times the derivative of x squared, which is 2x. So before, I can fill in the negative 1 now and see if I get an answer. On the top, I get negative 6 over 1 over 1 times 2 to the negative 1. It's 1 on the bottom because this one was squared. So I've got negative 6 over negative 3. And this choice for, sorry, negative 6 over negative 2, which in this choice is 3. Okay, number 6. So this has 2 ln's on it. I'm probably going to do a lot of canceling as I do this problem here. But if I put in infinity, I get infinity over infinity, which is indeterminate. So I'm going to L'Hopital the top and then L'Hopital the bottom. And I'm going to get 1 over x to the 5th times the derivative of x to the 5th, which is 5x to the 4th, over, parentheses, 1 over x plus 3, close parentheses to the 5th, times the derivative of that, which is 5x plus 3 to the 4th. And this will happen with all these ln problems. Watch this. Cancel, 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 cancel. And I'm left with 5 over x over 5 over x plus 3. Just to make my life easier, I'm going to bring the bottom fraction up by flipping it. 5 over x times x plus 3 over 5, which is equal to, I'm running out of room. I'll fit it in right here. I can do it. X approaches infinity of 5x plus 15 over 5x, If I substitute, I still get infinity over infinity. So I'll L'Hopital this one more time, and I get the limit as x approaches infinity of 5 over 5, which equals 1. All right, long way to get there, but with ln's usually cancel, bring the bottoms up and flip them, and you can usually find your answer from there. Okay, this next problem is a cosine 1. So if I stick in 0, I get cosine of 0 is 0, so I get 1 minus 1. Sorry, the cosine of 0 is 1. So I get 1 minus 1 over 1 minus 1. I get 0 over 0, which is indeterminate. So I'm going to apply L'Hopital's rule, and I'm going to take the derivative of the top. The derivative of cosine is negative sine, so it's negative sine of 4x times the derivative of the inside, which is 4, over derivative of cosine of 2x is negative sine 2x times the derivative of the inside, which is 2. And I'm just going to simplify this so I don't have to, so x approaches 0. So the sine of this becomes positive, and it's 4 sine 4x over negative 2 sine 2x. If I fill in 0, the sine of 0 is 0. I get 0 over 0 once again. So I'm going to L'Hopital it one more time. That usually is enough to get the answer. So the derivative of 4 times the sine of something is 4 times the cosine of something, times the derivative of the inside one more time, which is 4, over negative 2 cosine 2x, times the derivative of the inside, which is 2. I'm going to simplify it. 16 cosine 4x over negative 4 cosine 2x. If I fill in 0, I get cosine of 0 is 1. I get 16 over negative 4. So my answer is negative 4. Okay, here's number 8. I see 2 ln things. I guarantee a lot of stuff is going to cancel out. If I put in infinity, the ln of infinity is still infinity over infinity, indeterminate. Let's L'Hopital it. Infinity, so it's 1 over x plus 3 to the third times the derivative of x plus 3 to the third, which is 3x plus 3 squared, over 1 over x to the fifth times 5x to the fourth. And now I'm not going to try to substitute infinity in because I'm going to cancel some things out. It'll always happen with ln's. Gone, 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 and I'm left with 3 over x plus 3 over 5 over x, which I'm then going to turn into one fraction, which equals 3 over x plus 3 times x over 5, which equals 3x over 5x plus 3. Substitute in infinity, because I have one simple fraction now. I get infinity over infinity again. I'll L'Hopital it one last time. There's 3 over 5. The shorter way to do this one is when you get to this point. When you're heading towards infinity, only the biggest exponent matters. You can throw those out and cancel and get 3/5. Okay, so the next function has some e's on there. It also has some parentheses. I don't know if I really like that. So what I'm going to do is I'm going to fill in 0. And I get 0 over 0 on the top. So I can go ahead and L'Hopital it. Now, if you want to multiply that 5 into the top, you can. But just so you know, when you take a derivative, there's a constant out front. You just keep the constant and take the derivative of the rest of the stuff. So it becomes e to the x minus 0 minus 1 over, the derivative of cosine is negative sine, so negative sine, the sine of x. If I fill in my 0, I get 1 minus 1 on the top, 0 over 0 on the bottom. Sorry, 0 on the bottom, I get it again. So I'll L'Hopital it one more time. I'll keep that 5. The inside is e to the x. The sine is cosine of x. So on the top, I get e to the 0 e to the 0, which is 1, times 5 is 5. And the cosine of 0 is 1. So my answer for 9 is 5. And then my last problem, which is a very common one for them to put on the AP. If I fill in infinity, I get infinity over infinity. So I'll L'Hopital it. Period of e to the x is e to the x. E to the x squared is 2x. Fill infinity, I get infinity over infinity again. Take the derivative, e to the x over 2. So put infinity in the top, I get infinity over 2, which is the same as infinity. This limit is infinite. I actually kind of knew that because of what was going on right here. This one isn't going to reduce down in size. This is going to keep shrinking away. So I know it's going to have that on the top. So once again, non-mandatory video, but it can help you with your homework. If you have any questions, I'll talk to you tomorrow. Goodbye.